Composite Design. Overview. The Composite Design tool for Revit can be used to design composite floors according to AISC standards. It is complex to use and imposes several restrictions on the geometric and analytical setup of the Revit model. At the same time, the tool is also very powerful. One of those restrictions is that only AISC standard wide flange steel sections can be used. The content generator from the Revit extensions can be used to access AISC conform wide flange beams. The comprehensive help file is pointing out detailed instructions on how to set up the model to use this tool reliably and efficiently. It also provides information about the standard, formulas, analytical considerations, and usage. The help file is accessible by hitting the F1 key while in the module. Also, ensure that proper material definitions are applied in the slab definition. Otherwise, an error message will appear and the tool won't start. Exercise. To follow this exercise, open the SU002 sample project model from the Open dialog box and open the standard 3D view. Select all elements from the sample building and use the filter tool to select and delete only the 4-point loads. They are not necessary for this exercise and prevent the Composite Design tool to start. Click on the right side of the view cube to select the composite slab, including all applied area loads and supporting beams comfortably. Hit HI on the keyboard to isolate the selection. While all elements are still selected, start the Composite Design tool from the Extensions ribbon. The Geometry dialog is displaying the geometric and material properties of the selected element. Beams are colored according to their utilization ratio. This ratio is determined by calculations according to AISC, but also by the settings defined in the Composite Settings. Select Composite Settings in the Edit menu and browse through the 4 different tabs, allowing you to adjust the calculation environment. Leave the settings as they are and hit OK. Open the Cases and Combinations dialog, which displays all load cases and combinations according to AISC standard for Composite Design. Proceed to the Loads dialog. This dialog is showing the loads considered for the framing member that is selected in the view window. The tool automatically transfers the external loads from the slab onto the framing members below. Static calculation reveals detailed information about calculation results, including moment diagrams, etc. Select the center beam in the view window and browse through the results. As with most other analysis modules, you can apply characteristic points via the Edit menu to show the results at interesting points. Select the Beam tab and add a couple of characteristic points. The Extreme Results dialog offers a quick overview about minimum and maximum displacements, internal forces, as well as reactions. Open the Design dialog and select Design All Beams. This will run through all AISC-conform wide flange beam sections and select the best matching section for each individual element according to the defined composite settings in the Edit menu. Once the design is finished, open the Report dialog to produce a report for each separate framing member. Select a member in the selection window, open the Report tab, and choose the information to appear in the report via the tick boxes. Preview the report and, when happy with it, select File menu to either save the report as an HTML file, print, or export straight to Word or Excel. To finalize this exercise, select OK to apply the optimized beam sections to the Revit model. Notice that the Revit model updates automatically according to the optimization results in the CompositeDesign tool. And this concludes the exercise CompositeDesign. And this concludes the module SU002 Structural Analysis Tools.